Hi everybody, and welcome to another Rubrik demo. I'm Mike Preston, and today we're going to take a look at tag-based protection, a super cool feature from our AWS Cloud Native Protection offering within Polaris. AWS tags are essentially metadata that we can apply to our resources running within AWS. A tag basically consists of two things, a key, or a name for the tag, and a specified value. Organizations commonly use these tags to make their environments easier to manage, make their resources easier to search for and to filter, and tags also provide a means to create automation and orchestration amongst a subset of resources. For example, organizations commonly use AWS tags to identify resources by purpose, like these EC2 and RDS instances make up my HR application. Or we can tag resources with an owner so we always know who to get in contact with. Or, quite commonly, we see tags used to define environments, declaring these resources are tests and these resources are production. We can then programmatically run tests and scripts against only the test environment. For these reasons, we see organizations utilizing a lot of time and resources and putting a lot of thought into their tagging strategy within AWS. And in Rubrik Polaris, we've integrated that same logic into how we protect your AWS environment. You can leverage those existing tags or create new ones and apply those to your data management processes. This is all handled by a concept called tag rules. Let's go have a look. So before we jump into the lab, let's take a look at how tag-based protection actually works. Tag-based protection uses something within Polaris called tag rules. And tag rules essentially map AWS resource tags to SLA domains within Rubrik Polaris. Now, tag rules are applied with the following workflow. First, tag rules are created. So when we create the tag rule, we essentially map AWS tags to SLA domains. So in this case, you can see we're mapping a tag called backup. If its value is gold, it maps to the gold SLA domain. If its value is silver, it maps to an SLA domain named silver. And if its value is exclude, it actually sets that EC2 instance or RDS deployment to do not protect. So we go ahead, set up our tag rules within Polaris, and then simply assign tags to resources within AWS. Polaris then scans the environment during the creation of the tag rule and periodically after that, and applies the SLA domains to the objects which are tagged appropriately. We can see a number of instances and EBS volumes got mapped to the gold SLA domain, the silver SLA domain, and, of course, do not protect. As any tags are changed or we have any newly added resources with the appropriate tags, Polaris will scan and update all of the SLA domain configuration appropriately. Now, since we can have multiple tags on EC2 resources and multiple tags on EBS volumes, there is a chance that an object will match multiple tag rules. In the event that this happens, Polaris will select one rule to apply based off the following precedents. If a tag rule specifies do not protect, this takes precedence over everything else. If this isn't the case, it then selects whichever SLA domain has the most frequent snapshots. And finally, if that's a match as well, it'll choose the SLA domain that's retaining data the longest. So now that we know how tag-based protection actually works, let's go over the scenario we're going to run through today. Now, to help things seem more realistic and apply what we're going through to a more real-world experience, we're going to use our fictitious company here at Rubrik called Zafra Fashion Group. And more specifically, we're going to focus on the application and the architecture of that application that powers their human resources. So currently this application is running within AWS in the US East 1 region. And it consists of 2 web servers, an application server, and a Postgres server running on RDS. Now the web servers are deployed in different availability zones, and they're sitting behind a network load balancer as well. And the Postgres database, which hosts all the data, is running within RDS with a read replica already configured in US West 2, so we don't have to worry about that. Also, Zafra is protecting this whole AWS environment with Rubrik Polaris. They do already have a tag rule configured, which includes EC2 and EBS instances which have an environment tag set to production. So all of the instances and RDS instances that we see here will be protected by the ZFG production SLA domain. Now this SLA domain will create a number of EBS volume snapshots and AMIs within the US East 1 region as it backs up all of Zafra's data. Now this SLA domain is also protecting more than just the HR application, right? It's protecting many other EC2 instances that Zafra has within their AWS environment. So one day, the big boss comes down and says, you know what? I want to make sure that we can recover in the event of a regional level failure. And I want all of the data to be recovered in US West 2. He's very, very specific. They also state that, we don't really have budget for any of this, so this should really have a minimal impact on our operating costs and should really take minimal effort because I need you to continue doing everything else that you do as you design this. Now, there's a number of ways we can do this. We could re-architect the HR application itself. We could utilize a number of resources within AWS in order to move the data to a different region. But the key is here, it has to be with minimal effort and it has to have minimal impact on operating costs. So the solution we'll walk through is using Rubrik Polaris. Now what we'll walk through in just a moment is creating a new SLA domain called ZFG replication. Now within this SLA domain, we'll actually create something called cross-region replication, and we'll set the target of that up to US West 2. What this does is any objects that are assigned to the SLA domain, when it creates those AMIs and EBS snapshots and volume snapshots, it will actually replicate them over to US West 2, allowing us to restore our EC2 instances there. So we'll create a tag rule to go along with that SLA domain, and we'll create new tags on all of the HR resources within AWS. We'll set up a tag called replication and its value to US West 2. Our tag rule will then pick up any instance that has replication with a value of US West 2 and apply that SLA domain to it. Now this solution also hits a number of items within the AWS well-architected framework. First, we have reliability. We're definitely mitigating that risk of using a single region to store our AMIs and snapshot data. Our remote region, in this case US West 2, can be utilized in the event that data in the local region becomes unavailable. Second, we touch the operationally efficient item. We're choosing the solution with the least amount of effort. Sure, there are a lot of different ways we can accomplish this, but utilizing Rubrik Polaris and tag rules is a lot easier than babysitting scripts and making sure cron jobs have run. Thirdly is cost optimization. Remember, we have no budget, so we're actually delivering the requirements using the lowest cost option. Fourth is security. Data needs to remain immutable and safe from external threats. And finally, we have performance. We're enabling recovery using data in the remote AWS region, and we're also doing that within the defined application owner's SLA. So as much as I love talking about what we're going to do and telling you how it works, I love showing you even more. So let's jump into Zafra's environment and get this all configured. Okay, so here we are within Zafra's Polaris instance, and the first thing I want to look at is the current state of their EC2 protection. To do that, I'll head up to Inventory, and then I'll select EC2. Now, a lot of organizations utilize multiple AWS accounts, and Polaris fully supports that. So the first thing I'm going to do is I'm going to go ahead and filter by just the Rubrik-TM account, as I know that's where those HR instances live. Now again, we have a number of instances showing up here, so I'm going to go ahead and just sort of filter everything by typing HR into the search field. So now we can see our 3 EC2 instances that make up that application, our 2 web servers and our application server. We can see they're running in US East 1. We can see that they're assigned to the ZFG production SLA domain. And that assignment is actually derived from a tag rule. So let's go ahead and check out that existing tag rule. That can be found up here just by clicking tag rules. And the one we're looking for is tm environment-prod-ec2. Let's go have a look. So as you can see, tag rules are pretty simple. They simply get a name, then you associate whatever tags you want to associate with them. And another nifty feature is we can apply them to multiple AWS accounts. So they're not restrictive to just one account. So again, If you have multiple AWS accounts for your organization, you're probably using a similar type tagging strategy across them all. We allow you to continue using that strategy within Polaris. The next part of a tag rule is simply assigning it to an SLA domain. Here we can see this tag rule is assigned to the ZFG-production SLA domain. Now, if you can remember back to the slides, we were going to create a new tag rule that parses the replication tag. However, before we can do this, we need to create the associated SLA domain that we're going to map that tag rule to. So to do that, we're simply going to go up to SLA domains, and then we're going to create a new SLA domain. Now let's go ahead and set this SLA domain to say, take a backup every 6 hours, and we'll keep it for 3 days. That'll be enough to get us going here. Now from the remote policies section, this is where we are going to enable the cross-region replication. We'll toggle that on with the slider bar here. Under replication target, we're simply going to select an AWS region, and we'll go ahead and we'll select US West 2. We also want to specify how long we want to keep these around. So let's keep them for, let's say, 3 days. Click Next. Finally, we just give our SLA domain a name and click Submit. With that, we're done. We have our new SLA domain, and we can get started on creating that tag rule. So let's head back into our EC2 inventory. We'll head to the tag rules section, and we'll select to create a new tag rule. In this case, we're going to protect our EC2 instances. So let's go ahead and give the tag rule a name. I'm going to try and use the same naming convention. It's going to be tm-replication US West 2. Then we need to actually select the tags that we want to apply this tag rule to. So we're going to say the replication tag, if its value is US West 2, we're going to go ahead and apply this tag rule to it. I'm also going to specify that this is only applicable to the rubric-tm account. We'll click Next. We'll go ahead and assign that to our new replication SLA domain and click Submit. So as you can see, we don't have any protected objects within the ZFG replication SLA domain yet, and that's because we haven't actually tagged those EC2 instances yet. So let's head into the AWS console and check things out there. Okay, so here we are in our EC2 environment. You can see we have 3 running instances. Those will be the 3 instances that make up our HR application. If we come down here and check out what snapshots we have, because remember, these instances are already part of an SLA domain, we can actually see all of the snapshots that Polaris has created directly from within the AWS console. Now just a note, Polaris will create these snapshots of all the EBS volumes belonging to an EC2 instance with instance level consistency. Now what this means is that all of the EBS volumes attached to the EC2 instance are going to be consistent within the snapshots to the exact point in time the snapshot was taken. If we head back up to our instances, we can see our tags that are applied. Now, as you see, this environment tag with a value of production is what is mapping that EC2 instance to the ZFG production SLA domain. We need to actually add new tag to this called replication and set it to US West 2 in order to apply it to the new SLA domain we just created. Now we could do that manually if we wanted to, right directly from within the AWS console here. And it might not be too painful because we're only doing it on 3 different EC2 instances in this case. However, a more common approach would probably be to script this because you'd probably have hundreds if not thousands of instances that you might need to do this to. So today we'll use Terraform. So let's head over to VS Code and we'll add these tags via Terraform. All right, so here we are within our Terraform plan that was used to create these instances. And it's a pretty simple plan. We just simply run the AWS instance to create all of our different EC2 instances. We attach a couple of volumes to one of them, and then we can see we go ahead and create our RDS database instance as well. Now, in order to add the required tags that we want, we have to go and modify the actual variable, which is defined within the vars.tf file. So let's go ahead and add that tag that we need. If you remember, we were going to call it replication, and US West 2 is what we're going to set for the value. So I'm going to go ahead and copy and paste this onto all of the different instances that I want to apply it to, which is going to be the 2 web servers, the application server, as well as the database server. We'll go ahead and save that file, and then let's start with our Terraform plan. Okay, so plan run, it can say that we have 4 to change here. If we go and check out what's going on, we can see it is indeed that replication tag, which is going to be added to the 3 EC2 instances as well as the database RDS instance. So let's go ahead and run a Terraform apply. All right, Terraform says it's applied the tag for us. So let's head into the AWS console and check it out. Okay, back here in the console, should be able to see if we give this a little bit of a refresh, the new tag called replication with US West 2 as the value. So now that these instances are actually tagged, we should be able to see them back in Polaris. Okay, back in Polaris, we'll head into our inventory, head back to that same EC2 account. And if we filter by those HR EC2 instances, they have been reassigned to our replication SLA domain. You can also see that assignment now says it's derived from that new tag rule that we've created. So I'm going to give this a little time to run and a little time for backups and snapshots and all the replication to complete. And when I come back, we'll actually do a restore within US West 2 in order to make sure this works. Okay, we've given that a little time, and we can see here in Polaris, as I'm on the overview for the ZFG HR App 01 EC2 instance, that we have indeed generated some snapshots or some backups, and they have indeed been replicated for us. So let's jump into the EC2 console and see what that looks like. Okay, we'll just switch our region here because we replicated from US East 1 to US West 2. So let's go take a look at what we can see within US West 2. We'll head over to snapshots, and we can see that we do have data from US East 1 that Rubrik Polaris has replicated for us over to US West 2. This fulfills that reliability requirement we had where we needed to mitigate the risk of using a single region. We now have data in 2 different regions. I should note here as well that no data has left Zafra's account. Only metadata around the snapshots is sent back to Rubrik Polaris. The customer data, or the data on the EBS volumes, all remains within Zafra's account. And we've also fulfilled that cost optimization requirement as well here, as these snapshots will be pruned and deleted and removed based on the retention that we set up within the SLA. So we could set this up to use as little storage as possible and keep our costs down. So let's jump back into Polaris and actually restore one of these. All right, so I'm going to go ahead and select the latest snapshot that we have on the system. And when I click the little ellipsis, we can see we have a couple different options. We have export and restore. Well, restore does what you think it would do, right? Restore is going to overwrite basically the source EC2 instance with the data that's in these EBS volume snapshots. Export, however, lets us spin up a new copy or a new EC2 instance based off the data that we have in the EBS volume snapshots. So let's go ahead and select export. Now the first option here where it says export from, I should mention that you do not need to have cross-region replication enabled in order to export into a different region. In fact, we could have exported the original snapshots, which were stored in US East 1, directly to US West 2. The advantages of cross-region replication are that now we won't have to wait for those snapshots to be copied over to US West 2 before we can actually spin up the EC2 instances. So I'm going to go ahead and instruct this process to export from the actual replicated copy. I'm just going to append on the name export, and we do have some options here if we want to change the size of the EC2 instance while we're exporting. So we could essentially export this T2 micro into a bigger EC2 instance with more disk, more memory, more CPU. I'm going to leave it as it is. I'm going to go ahead and clear the region selection and make sure we are exporting into US West 2. Now our source EC2 instance was not encrypted, but we do have the ability to encrypt our exported EC2 instance. So if I wanted to, I could select a KMS key ID in order to encrypt that instance. Also, if our source EC2 instance was encrypted, we could essentially change the encryption key ID as well during the export process. Same goes for key pairs. We can select a new key pair. I'm going to go ahead and select the demo key pair that we have set up. And then I'm just going to go through and I'm going to find a spot in a VPC for it, give it a subnet, and assign it a security group. I'm going to leave this option checked to export the tags. That way, any tags that were assigned to the source EC2 instance will automatically be assigned to our exported EC2 instance. And it's as simple as that. We just click export, and away we go. We can track the progress by heading to the Events tab. This will list all of the events that are going on with this EC2 instance at the time, and we can see here that the recovery process is running, and it's already successfully launched the EC2 instance. So let's head back into AWS and check it out. All right, let's head to instances so we can see what's running. And we do see our HR application EC2 instance -export that we just recovered. Right now it's in an instant state of stopping. It's probably shutting down and it's detaching the root level disk and then reattaching the group of instant consistent snapshots that it took during the backup process. And now we can see the actual instance has switched to running. So you can see how quickly and how easily that is to spin up EC2 instances in another region. This definitely fulfills the performance requirement that we had. And as far as the operational efficiency requirement, if you can remember, we selected to restore the actual source tags. So when we go look at the tags on this EC2 instance, our replication tag is still there, our environment tag is still there, our creation source tag is still there. So we don't have to recreate these. As well, remember those tag rules we set up? Well, if we head back to Polaris and we go check out our replication SLA domain, we can see that it's already picked up the new instance that we just exported. So there's no need using tag-based protection to go and re-protect these EC2 instances as you restore or export them to different regions. So in summary, what did we actually do here? Well, we've seen the initial problem of Zafra having those EC2 instances all combined underneath US East 1. They had the requirement to be able to restore these things in the event of a region-level disaster. In the end, they were able to use Rubrik Polaris to take those EBS volume snapshots within US East 1 and replicate them to US West 2. They could then take those snapshots that were stored in US West 2 and spark up new EC2 instances. So how did we make out in terms of the well-architected framework? Well, you remember that first requirement, reliability, right? We wanted to mitigate the risk of using a single region to store our AMIs and snapshots. Well, the snapshots and AMIs that we generated were now being replicated to US West 2. So we do have these snapshots available in two different regions. As far as being operationally efficient, right, we wanted to choose the solution with the least effort. Well, tag rules, number one, allowed us to follow business logic. And the sheer fact that we could recover and export these same tags with our new instances means we didn't have to go back and set up Rubrik to protect the EC2 instance that it created. Finally, we have cost optimization. We want to deliver the requirements using that lowest cost option. Well, number one, we don't have to store piles and piles of snapshots, right? They're going to be expired and pruned off based on the information or that declarative policy that we set forth within the SLA domain. We then had security. We wanted to ensure that data should remain immutable and free and safe from external threats. Well, the Snapshot and AMI data that's generated never actually leaves the customer's account. Only metadata around file indexing and different things like that is sent back to Polaris. The data itself, the customer's data, remains within their AWS account. And then finally we had performance, right? We wanted to make sure that we could restore within the defined SLAs. Well, as we just saw, an instance can be recovered very, very quickly using Rubrik Polaris, and to any point in time that we have available. In fact, even if we didn't enable cross-region replication, the snapshot data and the AMI data would have been copied across to the region before we actually exported it. But nonetheless, it's always recoverable. So, I hope you enjoyed that demo and really hope it illustrated how you can take tag-based protection and integrate it into your own AWS tagging strategy. This will save you both time and cost while ensuring optimal performance and availability. Check out the description below for some links if you want to learn more about Rubrik Polaris and its cloud-native offerings. We have a great How It Works document which goes deep into the technical realm of how we protect and restore data within AWS. Also, we have an architecture reference around our fictitious company Zafra Fashion Group. This outlines how their workloads within AWS are architected and deployed, along with how Rubrik can fit into the mix. As always, any comments and questions are welcome. Please reach out, and thanks for watching.